So I just came up with this one here. Let's suppose we have a spherical balloon, and it's being inflated at a rate of 30 cubic inches per minute. At what time is the balloon's diameter increasing at a rate of 1 inch per minute? And here we have the volume of a sphere up here. So just like all of us in the beginning of calculus, we just want to take derivatives. And here this is a perfect case for implicit differentiation. Just imagine this volume is a function of time, and the radius is a function of time. And the radius is being a function of time. We could also say that the diameter is a function of time. So let's write the volume as a function of the diameter. So we have V is equal to 4/3 pi times the diameter, right? Because we're going after the diameter here. Diameter divided by 2, that's just the radius, cubed. And let's simplify this a little bit. The volume is equal to 4/3 pi d cubed over 8. This is just going to help us in the beginning. So we have 4 divided by 8 is 2, so this is the volume is equal to 1/6 pi times the diameter cubed. Okay, so now let's rip this apart with some derivatives. We're going to take the derivative of everything with respect to time. So what do we have? We have dv dt is equal to 1/6 pi times 2 times the diameter squared dd, the derivative of the diameter with respect to time. Well, let's simplify this a little bit more since we have a 2 and a 6 here. This says that dv dt is equal to pi over 3 d squared dd dt. And well, we have, let's see what we have up here. We have the rate the volume is changing, and we have the rate that let me do that in a different color. The rate that the diameter should be increasing. Well, there's the rate that the diameter should be increasing, and there's the rate that the volume should be increasing. So we can solve this for d squared. So let's do it. We have, let's put it right in here like this. dv dt is 30, and we should make sure that the units are the same. We're talking about inches and minutes, so we're okay there. Is equal to pi over 3 d squared, which is what we're going to get out, times d, the derivative of the diameter with respect to time, and we say that that's 1. Well, we just solve this for d squared, and let me work this way, just so I don't lose too much space. This is d squared is equal to 90 divided by pi. And then we can say that the diameter is equal to square root of 90 over pi. Now, before I rush to my calculator, let's just keep working with this. I might have to rush to my calculator soon, but let's see. So this is the diameter right here, the diameter of the balloon right here when we have, let's draw that dashed line, the diameter we have at this moment is the square root of 90 divided by. We can find the volume when the diameter is equal to that. Right? We can find out exactly what the volume is. And why do we want to find the volume? Well, that'll be clear in just a second if you stay with me. Well, you know what? I'll go ahead. Once we find the volume at that particular time, we know that the volume was increasing at 30 inches. So this is going to be a certain number of inches, cubic inches. So whatever that is, let's say it's going to be V cubic inches. I'll do it in a different color. Let's say we know that it's going to be V cubic inches. Well, we know how fast the volume was increasing. It was increasing at 30 cubic inches per minute. So once we have this, we can divide this by 30 cubic inches, cubic inches per minute, and that will give us, if you look at this dimensionally, right, we have cubic inches divided by cubic inches per minute, we will get the number of minutes that it took us to get to that volume. Okay, so that's where we're headed. Okay, so let's find the volume from, and this is going to be our model over here. Our volume at this time, when the diameter is the square root of 90 over pi, our volume is going to be, that is at the exact time we're thinking about. This is equal to 4/3 pi. So we're going back to our original function up here. 4/3 pi r cubed. Well, this is our diameter, so our r is 1/2 square root 90 over pi cubed. Now what is that? I don't know if it's time to go to the calculator yet. 4/3 pi 1/2 cubed is 1/8, and we have square root of 90 over pi cubed. This is going to give us our volume at that particular time, and I am going to go to my calculator at this point. So the volume at that time is equal to 14.41 cubic inches. And we know that it was a steady rate. We were pumping air into this balloon, and if we divide by, following this model over here, divide by 30 cubic inches per minute, we come up with 0.48 minutes, which is the same, it's roughly the same as 29 seconds. So that is the answer to this question. The balloon is being inflated at 30 cubic inches per minute. When is the balloon's diameter increasing at 1 inch per minute? It's occurring at 29 seconds. I love that problem.